On the next problem, 42, we want to do the same thing. So let's see how this plays. I'm going to go ahead and take this and write it in augmented matrix form. And that's going to look like a 3, a 3, and a 3, a 4, a 2, and an 8 third. We could reduce those, meaning I could divide the top row by a 3, but I'm not going to go there. I'm going to proceed and say, all right, my goal is to make this a 0. How do you do that? It's easier to multiply the top by, divide the top by a 3, but for now, let's say you multiply the top by a 4, the bottom by a 3, make one of them negative, it doesn't matter which one, and put the result where? We want the result to stay in this row. So we want row 2 to be that. Well, here I need to multiply the top row by a 4. That becomes a 12, a 12, and a 12. The bottom by a negative 3, negative 12, negative 6, and negative 8. And if I add those two, oh man, I can get it right. 12 minus 12 is a 0, and the reason I'm keeping that there because I want it in row 2. And 12 minus 6 is a 6, and 12 minus 8 is a 4. The top row, I just used it. I'm not going to do anything else, and I'm done again. This says 6y equal a 4, which means y equals 2 thirds. And I go backward substitution. You go up, say, well, 3x plus 3, I know y is 2 thirds. That's a 3. Doesn't that indicate that 3x plus 2 equal 3? Subtract, that's 1, so x is 1 third. So the solution to this system of equations is x equal 1 third and y equals 2 thirds. That's for a 2 by 2. Now we're going to try a 3 by 3 and see how that plays. So on this problem, we're going to write the augmented matrix. Now this is going to take literally 3 steps. So that's the good news. You know already how many steps it's going to take to solve those. You just have to work slowly. So 2x, 1y, there is no z. There's no x. Just be careful when you line them up. And I'm going to show you a way if you really want, you don't have to. So you could say, you know what, they're trying to trick us. That's really what that says. This says 0x minus 2y plus 4z equals 0. And this says 3x plus 0y. Normally you don't write the 0. Kind of like, remember when you did syntactic division, you really had to compensate for whatever is missing the terms. So here now, since I have more than one, I have more than 2, that is more than 1 to get rid of. My first goal is to make those two 0. That's always how it works. This is already 0. Well, okay, good. I need to make that a 0. Now the author will divide this by 2 every time to make it a 1. We don't do that. We do that at the end. So I want to make that a 0. How do I do that? If I multiply the top equation by a 3, and I multiply the last equation by a 2 and make one of them negative. And I'll put the result in row 3. That'll do it. So if I do that, let's see what would happen. I'll be looking at the first equation. I'm not changing. The only thing that's changing is this row. Nothing else. If I multiply row 1 by 3, that becomes a 6, a 3, a 0, and a negative 12. If I multiply row 3 by a negative 2, that becomes a negative 6, a 0, a 4, and a 22. And if I add those, I'll get a 0, 3, 4, and a 10. Now, the second step, so this is it. The second step, I will make that a 0, but I'll make sure I only use those 2 rows, because If I use row 1, I'll alter those back. I don't want to do that. So how do you do that? Looking at those two numbers, how do you make that a 0? Well, hey, multiply the top by a 3. That's row 2. That's what the top is in this case. Multiply the bottom by a 2. Add the 2. That's pretty much it. And where do you want the result? Again, I want this new value right there. So I want that in row 3. Well, multiplying this row by a 3, that makes that a 0, negative 6, a 12, and a 0. Multiplying this by a 2, a 0, 6, an 8, and a 20. And if I add those, what do I get? If I add those, I'll get a 0, 0, 20, and a 20. And I didn't really change row 2 or row 1, the new row 2 or row 1, so here they are. And like I said, if you just want to get one of those, it takes 2 steps and you're done. This says 20y equals 20, which means y is 1. I'm sorry, did I say y? I meant z, x, y, and z. Go back one level. Now, negative 2y plus 4, but I know z is 1 is 0. That's this row. So that means move it. That's negative 4. Y is 2. Go up a level, and we would say 2x plus 1y, but we know y is a 2, equal a negative 4. That's negative 6. So x is a negative 3. So we say the solution here is negative 3, 2, and a 1. These are the values. Once substituted in the first equation, they give a negative 4. In the second equation, they give a 0. And in the third equation, they give a negative 11, which is the definition of a solution to a system of equations. The next problem I want to look at is number 52. So now that we are getting more comfortable with this, hopefully we could try it as well. One thing about those, there's a lot of calculations, so you really want to work slowly, otherwise the chances of making a mistake is very high. So my first order of business, I want to make those two a 0. How do I do that? Well, I could take row 1, add it to row 2, put the result in row 2, or simply let row 2 equal that. Well, let me start with that. So my first step, if I take those two and I add them, put the result in row 2, that's a 0, that's a 3, that's a 4, and that's a negative 7. Now, if I want to make that a 0, I'm going to multiply. Now, I have a couple of options. I could say multiply row 2 by 3, row 3 by 2, and add them. Since row 2, this is negative. I could say take row 1, multiply it by negative 2, and add it to that row. The author doesn't like what I just did, but I'm going to do it anyways. So, if I multiply this row by 3, doesn't that make it negative 6, 6, and a negative 21? Oops, I missed one. If I multiply this by a 3, negative 6, 6, I'm sorry, by 3, negative 6, 6, 3, and 21. If I multiply this by a 2, doesn't that become a 6, a negative 8, a negative 6, and a 14? And if I add those, what do I get? 0, negative 2, a negative 3, and a negative 7. Now, if I want to make the next step, I want to make that a 0 by using those two, and only those two. Well, let's see how that works. If I multiply row 2 by what? By 2. Row 3 by 3 and add the 2. Wouldn't that work? Row 1, leave it alone. Row 2, leave it alone because I want to put the result in row 3. So this is the only row that's going to change. If I multiply the top by a 2, that's 0, 6, 8, and 14. Is that right? Yeah. And the bottom by 3. I'll get a 0, a negative 6, a 3, negative 9, and negative 21. And if I add those, I'll get a 0, 0, negative 1, and what is that? Negative 35. That says z equal 35 because negative z equal 35. Backward substitution. I'll get 3y plus 4 times 35. What's 4 times 35? Well, that's a big number. That's 140 equal negative 7. So 3y equals negative 147. And y will equal negative 147 over 3. That doesn't look right. That divides. Negative 49. And then we go back up to the first and say 2x minus 49 plus 3570, 105 equals 0. So 2x equal negative 56. So divide by 2. X equal negative 28. So again, negative 28, negative 49, and 35 would be the solution to this system. The next number is number 54. Let me do that before the end of time. So if I write the augmented matrix, I will notice to make those two zeros, well, if I take row 1 plus 2 row 2, put that in row 2, that will work. And if I take 3 row 2 plus row 3, put that in row 3, that will do the trick. And let's see how that works. 2, negative 3, negative 1, and a 0. If I multiply this by 2, I'm looking at row 1, row 2 by 2, that's negative 2, a 4, a 2, and a 10. And if I add those, that's a 0, 1, 1, and a 10. And if I multiply this by negative 3, that's negative 3, 6, 3, and 15. And if I add those, I will get a 0, 2, 2, and a 14. And now if I take negative row 2 plus row 3 multiplied by 2, let row 3 equal that, what would happen? 2, negative 3, negative 1, and a 0. 0, 1, 1, and a 10. If I multiply this by a negative 2, that's 0, negative 2, negative 2, and negative 20. And if I add those, I'll get 0, 0, 0, and a negative 16. This says 0 times z equal negative 16, but 0 times any number is 0. This is saying 0 equal negative 16. That means there is no solution. And that concludes this section. And there's the homework. That concludes this section.